Rust takes a strong stance on error handling. Errors are always going to be present in software, and Rust tries to do its best in making the programmer acknowledge that there is a possibility of an error and an attempt to reduce bugs. So in this section, we are going to take a look at how error handling is done in Rust. Rust tries to help us out when it comes to handling errors in our programs. Firstly, Rust is going to group errors into two categories, recoverable and unrecoverable. Recoverable errors are going to rely on the result type, and then unrecoverable errors are going to use the panic macro. So let's start off by looking at the panic macro. The panic macro is going to terminate the current thread. So let's terminate our main thread, and we'll say panicked here. And now we'll run this, and we can see that it says thread main panicked at panicked here, which was our error message, or our panic message, I should say. One example that would cause a panic to occur is if we try to perform an out-of-bounds access on array. So let's look at that real quick. So let's create a vector, and let's just put in a value of 1. And now let's say that we want to access index 10 at the vector for whatever reason. So obviously the IDE does not signal that this is an error. But when we run this, it says thread main panicked at index out of bounds, which is right here. The length is 1, but the index is 10. So it was able to give us a good error message. But again, this index out of bounds caused a panic. So now we see that it says note run with rust underscore backtrace equals 1 environment variable to display a backtrace. So let's do that real quick, and I'm doing this on Windows. So for me to set the environment variable, I run this command right here to set rust backtrace equal to 1. So now that I have it and we run cargo run again, we see that I have the backtrace printed out. So the backtrace is basically just going to give us a list of all the functions in a recursive order leading up to our error and to the program unwinding. So unwinding is the default behavior for handling a panic. The first thing we get is an error message printed to the terminal in this case. Then the stack starts to unwind. During this process, temporary values, local variables, current function arguments, etc. are all dropped in the reverse order they were created. Once the current function is cleaned up, it moves on to whoever called the function that panicked and performs the same unwinding process. Then eventually, after all the unwinding is completed, the thread exits. If the panicking thread was the main thread, the whole process exits, which is what we did in this case. There is another behavior that panicking can have, and that is called an abort. In the event of an abort, unwinding does not happen. For example, imagine we called a customize drop method during the unwinding process, but this drop method also panics. This would be considered fatal and causes the whole process to stop. And that's really all there is to it to panics. So now that we know how panics work, let's look at error handling that we can manage with recoverable errors. Before we talk about how to catch errors, let's talk about a result. Because most errors don't require the program to stop entirely. And for these errors, we use the result type. The result type is going to allow us to prepare in case there is a failure. Most failures we can predict or account for, so we can take some type of action to remediate these failures without having the program close. Result is an enum that has two variants, OK and error, and is defined like this. So we have, it's an enum called result, and has two generic variants, T and E. And then in here we have OK, T, and error, or however you want to say it, right there. So that is the result enum. So a very common case that we can look at real quick is, is opening a file. So let's bring in the file into scope, and then we can say let file equal file open, and remember these can fail, so we'll just call it error.txt, which obviously I have not created. But if we hover over the open method, we can see that we are being returned a result. So now that we know that a result is returned in these error possible scenarios, we can look at how to capture these errors. The most thorough way to catch errors is by using the match expression we learned about earlier on in this course. So let's create one. So we can say let file equals match file, and then if an OK is returned with the file, then just continue on with the file. But if an error is returned, then let's panic error, and then let's also pass in the error message that it gives us. So we know that we don't have an error.txt file to open, so we know that this is going to error out. So if we run this, we see that it panicked with our error message, error, and then we see OS code for operating system code 2, kind, not found, and then the message, the system cannot find the file specified. So we see that the error printed out an error kind of not found, which is information we can do something with. Error kind is provided by the standard library, so let's try to match on error kind. So what we can do is we can come up here and we can say use standard IO and then error kind, and now we can match on error kind. So we can delete this and say match error.kind, and now we have another match statement in here. So we can say error kind and then not found, and then match on this and say, because we want to create a new file called error.txt, so we want to create error.txt, and then because this can also fail, we want to say OK, file created, and then just say file created. Otherwise, we got an error here as well, and we want to panic, and it says cannot create the file. And now we have to have an exhaustive match, so down here we'll just do an underscore and say panic, it was some other error kind, which we know in this case it won't happen because we already know the error that we're going to get. So now if we run this, we didn't error out, and we see that error.txt was created for us. So great, so that's how we can use match statements, and we can even nest them to be able to handle logic for us. So another tool we have at our disposal is called unwrap. So I'm going to comment all of this out, and I'm actually going to just quickly rename this and just call it error2. That way we can keep generating errors. And now we can come up here and we can say unwrap. And what's going to happen in unwrap is if OK is returned from the method, then unwrap will return the value inside of OK for us. But if the result is an error, unwrap will call panic for us. So since we no longer have error.txt, I expect this to panic for us, which it does, and it said the thread main panicked at our unwrap method on an error value and then our normal error code. And then if we change this back to be a file that will be found, we no longer have an error. So if we want to customize our error, then we can use something called the expect. So instead of unwrap, we say expect, and then we pass in a string, error opening the file. And then we get rid of these extra parentheses. So again, we know that this is going to error out because we changed our file name again. So now if we run this, we see that it says error opening the file, and also gave us all the extra information regarding this. So expect is beneficial because it's going to allow us to much more quickly track down the source of the panic call in any of our logs. So in the next lecture, we're going to look at how we can propagate errors. So as you can imagine, if we always try to catch and handle the error immediately, that's going to be a lot of match statements, as we saw up here in this example. In this case, we can propagate the error up the call stack, and we can use this by using a question mark operator. And we can use a question mark to any expression that produces a result. On success, it unwraps the result to get the success value inside. But on error, it immediately returns from the enclosing function and passes the error result up the call chain. So let's look at how we can test this. So there's a couple of items we need to bring into scope. So we're going to use the file system and then rename. And then we're going to use standard IO and then error. So inside of main, we're going to actually call a function called let test equal open file. And now we want to create a function down here called open file. And it's going to return a result of either a file or an error. And now inside here we can say let file equal file open error.txt, and then on OK we just want to send back the file. And I want to put a question mark here because that's the whole purpose of this. So this question mark is how we can propagate the error up. So now if we run cargo run, everything looks good because we didn't use the test variable. So we'll say test.unwrap. And now if we run it, we see that our error was propagated up. So it says result unwrap on error value. So our error was indeed propagated up. But if we make this correct and run it, everything runs cleanly. So it's just a much easier way of handling these errors without having an enormous amount of match statements to kind of go along with them. So another example that we can look at is renaming a file, because renaming a file can fail as well. So we're going to have to return a result, and we'll just give it an empty, generic, and an error that can be returned. So we'll say let file equals rename, because we brought that into scope, and we'll say we'll rename from error.txt error.txt to renamed.txt. And then we will return the OK there, and we need to put our question mark there. So now we'll say here, we actually don't even have to do this. We'll say rename file, rename file dot unwrap. And now that we know that we have an error.txt created, we expect error.txt to be renamed to rename.txt file. And as you can see, that is what happens. So we cannot typically use the question mark operator in the main method because there is not anything for it to be passed up to. So in most cases, you would want to use expect in the main thread. But all in all, this is really all there is to error handling, aside from being able to generate our own custom errors, which we'll do later on in this course. But for now, that is practically all there is to it for general error handling.